Okay, continuing on, we're going to keep going with 27 and expand. So if we're expanding, this 4 needs to go in front of your natural log, or it needs to go to both of them. There are a few answers for this stuff. I'm going to distribute your 4 in and multiply it. So that'll be the natural log of 2 to the 4th, which is 2, 4, 8, 16, over a to the 12th. And then you're expanding it. So it's the natural log of 16. Since it's division, it's minus the natural log of a to the 12th. That's a 12. Doesn't look like it is. And then if there's ever an exponent, it has to get multiplied to the front of that one, or whatever it's being raised to. So natural log of 16 minus 12 natural log of a. Now, if you had expanded it from here, you would have gotten 3. Another possible answer you could have gotten is 3 natural log of 2 minus 3 natural log of a cubed. Was that a 4? I think it was a 4. Hold on. It was 4. 4. And then this would still have to be down. So 4 natural log of 2, or 3 times 4, 12 natural log of a. So I'd take either of those. Obviously, the last one's the same, but this is 2 to the 4th power. So if you bring the 4 to the front, that's the same. So whichever one you got, it's fine. Keep going. Odds. If you have a log on both sides, they're both log base 4, then you're just setting the insides equal to each other. So 5x plus 7 equals 2x plus 31, and that's what you're solving. So subtract over 2x, subtract over 7. 31 minus 7 is 24. Divide over by 3. X equals 8. Check your answer. Always check your answer. Log base 4. I'm going to bank this. 4 of 5 times 8 plus 7 equals log base 4, 2 times 8 plus 31. Sure. So you know 8's correct. Here you're going to have to factor, check both your answers. Here, bring up, condense it to 1 log, so you get log equals a number. So log base 8 of 36 to the 1/2. And then it's multiplication because it's 2 logs being added together. You're multiplying it to that whole thing. Equals to log base 8 of 132. 1/4, 36 to the 1/4. I'm sorry, 1/2 is the same thing as the square root of 36, and the square root of 36 is just 6. So we're doing 6 times 3k plus 7 equals 132. Because log 8 equals, distribute 6, 18k plus 7 equals 132. Minus over the 7, 125, divide over by 18. K equals 32 something wrong. 32. Yeah. Okay. So equals a fraction. It's a nice fraction. I don't know. Nope. I'll just leave it as a fraction instead of rounding and trying to get it wrong. And we'll check your answer. So 1/2. Always go back to the original in case you mess something up. 36 plus log base 8 of If you're ever not sure, go ahead and put parentheses, and if they're not needed, they'll go away. If they were needed, they'll stay. So just go ahead and put that in parentheses. And I'm just going to say log 8 of 32. Make sure that equals log 8 of 132. Does that equal log base 8 of 132? No, it doesn't. Something's wrong. It doesn't look like a rounding error either, so something went wrong. The square root of 36 is 6. I multiplied it. Oh, I didn't multiply the 6 and the 7. Why I check my answers. So that's 42. So then I'm going to subtract over 42 and get, can't think this early. 90. And then I'm going to divide that by 18. And get 5. 90 and get 5. And then I can check my answers. And I've already typed it all in, so I'm not going to waste my time. I got 5. Does that equal this? There we go. Now it does. Good reason to check my answers. So that works. Moving on. Simple distributing mistake. All right, if you have it as a log equals to a number and not 2 logs on each side, then you have to write it in exponential form. So 2 to the 7th, 2 to the 7th equals 9m plus 2. 2, 4, 8, 16, 32, 64. Subtract over your 2. Divide over by 9. I don't think that's a nice number. I'm just going to make 2 to the 7th. I was wrong. 2 to the 7th is 128. Oh my gosh, I'm struggling. 128. So I'm subtracting at 126, and 126 divided by 9 is 14. Whew. Check that answer. Got the question. 9 times 14 plus 2 equals 7. So you know you're right. That's busy. Keep going. Solving exponential equations. With exponential equations, see if you can get them right and it has the same base. So I think 4 to the 3rd is 64. Yes, 4 to the 3rd is 64. So if you can get them into the same base, then you can just set your exponents equal to each other. Because the bases are going to be the same on each. So once you set your exponents equal, make sure you distribute correctly. Made so many mistakes in this video. Subtract over 3x, I get 2x. Add over 3, I get 24. Divide over by 2, I get 12. Check your answer. Always check your answer. There's no reason not to check your answer. I'm checking it so I know I'm not teaching you wrong. 64 to the 12. I don't have my answer key, as you can tell. It's at school. Looks pretty good. Can't see the whole thing, but looks good. Yeah, it's huge, but it works. They're all the same. Okay. 8 multiples of 8 is 8 squared is 64, so it's not 8. 4 doesn't get me 8 because it'd be 4 or 16. 2 might work. 2, 4, 8, 16, 32, 64. 2 doesn't work because that won't get me 48. Kind of running out of options here. There's no multiple to get it. There's no base I can change so that they're both the same base like the one I just did. So that's when you have to use logarithms. Before we do that, we can know at least what the exponent should be around, just so you know your answer is right. 864. So it should 8 to the power 1, 8 to the power 2. It should be closer to 1. So n minus 5 should be closer to 1. But we have to take the log of it. So write in log form, log base 8 of 48 equals n minus 5. So just get good with those conversions. You're going to use that on all this test. You're just taking the log of 48, and I'm going to have to add over 5. So n equals log base 8 of 48. To add over 5 or subtract over 5? Add over 5. And then write everything you see. 6.861605. 6.16. Check your answer. Plug it in. 8 raised to the 6.86165 plus 5. Oh, minus 5. 47.9996, which rounds to 48. So 48. And that's why we're not rounding it. Because I mean, we did round it, but not drastically. That's the real answer if you were willing to write it all down. Let's see if the test says to round anything. Nope, doesn't say to round anything. So just give me the whole thing. All right. 39E. E is like pi, it never ends. So there's no way to get 64 as e raised to some number. So we have to change it into a log. Since it's a log based e of 65 equals a plus 1, that's the definition of the natural log. So I'm going to write natural log of 65, a plus 1. You won't get it wrong if you leave it as log base a. This just is easier to type in. Log base e, I'm sorry. It's just easier for me to type in. Subtract 1, I get a. Natural log of 65. Natural log of 65 minus 1. There you go. So that's e raised to 3.17439 plus 1 equals 65. 3, 17, 43, 9. 3, 17, 43, 9. There we go. Always check your answers. All right, exponential growth, y equals a parentheses 1 plus r to the t. Y equals a parentheses 1 minus r to the t. Remember, these rates are as a decimal. As a compound interest is y equals a parentheses 1 minus r over n to the t times n. So we have to figure out which equation to use. So if he invests $5,000, it increases at 2.3 each year. Each year means n is 1. And if n is 1, you're back to this equation. So, or this plus this equation. So my initial amount is 5,000. My rate as a percentage is 2.3%. So as a decimal, 2 places to the left, or if you don't like moving it 2 places to the left, just divide it by 100 and that will move it 2 places to the left for you. But 0.23. My time is 15 years, and I'm plugging it into increasing, so plus. Times 1 plus 0.023 to the 15. Seven, and if it's rounding funny, make sure you scroll up, hit enter, so you can round it to the 2 decimal places. My calculator was rounding it to the 2 decimal places. 2 decimal places. $7,032.42. $7,042.32. 42 cents. Oh my gosh. I'm getting it all wrong. That's what it is. $7,032.42. All right, last one. Miles invests 2,400 in a retirement account. It earns 1.8 compounded bi-monthly, twice a month. So since it's compounded, we're using the other equation, but it is earning, so it's plus. So our equation so y equals our initial amount, 2,400. Our rate is 1.8 as a percent. You need to make it a decimal. And our time is 25 years. So 2,400, 1 plus 0.018 over n, twice a month, 12 months. So we have 24 as our n. And that's what we're typing in the calculator. There's no way you can remember all that. 2,400 times 1 plus 0.018 over 24 raised to 24. I think it was times 25. Make sure I typed it in right. 3,000. Make sure it's rounding right. 3,763. 3,763.31. So that is the balance. If it asks how much interest will she have paid, I'm going to take the original amount and subtract it from my new one, and that'll show you the interest paid. Well, not technically on this one. That would be the interest earned. All right. Do all the evens, and we will go over them on Monday. Make sure this is all completed. We're going to turn it in completed on Monday for grade before we go over it. So attempt every problem.